Have you ever wondered, in the quiet of the night, how the universe will meet its end? It's a question that has echoed through the ages. From the earliest philosophers gazing at the stars, to today's leading cosmologists peering into the depths of space and time, the question of the universe's ultimate fate has always intrigued us. Our fascination with endings is a part of our human nature. We seek closure, resolution, and understanding of the final act. This curiosity extends beyond our own lives, beyond the lifespan of our species, and reaches out to encompass the cosmos itself. We ask ourselves, what will be the final chapter in the story of the universe? Scientists have proposed several theories about how the universe might meet its demise. Some of these theories are eerie, some are awe-inspiring, and some are downright terrifying. Yet, they all share a common thread. They remind us of the grand scale of the cosmos and our place within it. One of these theories suggests a slow and gradual end in a scenario known as the Big Freeze. Here, the universe continues to expand indefinitely, gradually cooling down until it reaches a state of maximum entropy, a cold, dark, and lifeless end. Another theory predicts a more cataclysmic outcome. The Big Crunch theory proposes that the universe's expansion will eventually reverse, causing everything to collapse back into a singularity, the same state from which the universe is believed to have originated. Yet another theory, the Big Rip, hypothesizes a future where the universe's expansion accelerates to such a degree that galaxies, stars, planets, and even atoms are torn apart. These theories are all fascinating in their own right, and each one provides a different perspective on the ultimate fate of the cosmos. But remember, these are theoretical scenarios based on our current understanding of the universe. As our knowledge grows, these theories may evolve, change, or even be replaced by new ones. So let's dive in and explore the possibilities of our universe's grand finale. The end may be billions of years away, but the journey to understand it begins now. Imagine, if you will, a universe slowly cooling down, its energy spreading out until all heat is gone. Welcome to the chilling concept of the Big Freeze. This theory, one of the leading hypotheses about the ultimate fate of our universe, paints a picture of a cosmos expanding indefinitely. Over unimaginable spans of time, this expansion dilutes the universe's energy, leading to a slow but inexorable cooling. The Big Freeze theory is rooted in our current understanding of the universe's expansion. Astrophysicists observe that galaxies are moving away from each other. This movement suggests that the universe is growing larger, a phenomenon explained by the concept of dark energy. This mysterious force is thought to be driving the universe's expansion, pushing galaxies further and further apart. Imagine a cup of hot tea in a cold room. Over time, the heat from the tea disperses into the room, reducing the temperature of the tea until it reaches room temperature. This is a simplified analogy for what the Big Freeze theory suggests will happen to our universe. As the universe expands, energy becomes more spread out, less concentrated. Stars will burn out, galaxies will dim, and eventually all heat will dissipate into the cold expanse of space. In this scenario, the universe doesn't meet a dramatic fiery end. Instead, it slowly fades into darkness, a process that takes billions upon billions of years. The universe becomes a vast cold void, devoid of the energy necessary for stars to burn and life to exist. This is a sobering perspective on the universe's destiny, a stark contrast to its fiery birth in the Big Bang. It is a reminder of the impermanence of even the most colossal and enduring structures in existence. In this future, the universe would end not with a bang, but with a whisper. Or perhaps the universe will one day begin to contract, pulling everything back to a single point. This idea, my friends, is the crux of a captivating theory known as the Big Crunch. This theory posits that the universe, which is currently expanding, may someday reach a point where this expansion halts and then reverses. Imagine a ball thrown into the air. After reaching a certain height, the ball stops for a split second before gravity pulls it back down. In a similar vein, the Big Crunch theory suggests that the universe might behave like that ball, reaching a maximum expansion point before gravity lures it back to its origins. Now, you might be wondering, what would this contraction look like? Well, it's essentially a rewind of the Big Bang, with galaxies, stars, and all matter spiraling inward, converging back to a singular, dense point. A point of infinite density, a point of singularity. What's intriguing about this theory is that it doesn't just predict an end, but it also opens up the possibility of a cyclical universe. Think of it like a cosmic phoenix, reborn from its own ashes. After each Big Crunch, a new universe could be born in a Big Bang, and this cycle of birth, death, and rebirth could continue indefinitely. Of course, it's important to remember that this is just a theory. The actual fate of our universe is still a hot topic of debate among scientists, with many leaning towards an eternal expansion rather than a Big Crunch. But the beauty of science is that it's always evolving, always questioning, and always open to new ideas. In the grand cosmic scheme of things, the Big Crunch theory is a humbling reminder of our universe's potential mortality. But it's also a testament to the enduring cycle of life and death, a cycle that might even extend beyond our own universe. This theory paints a picture of a universe in constant rebirth, each end leading to a new beginning. But what if the end of the universe is not gentle, but violent, tearing apart everything that exists? That's where the Big Rip theory comes in. This theory suggests that the universe's expansion isn't just going to continue, it's going to speed up. And not just a little bit, but to such a degree that it literally tears everything apart. Imagine the universe as a loaf of bread rising in the oven. As it bakes, it expands, growing larger and larger. Now imagine if that loaf of bread kept expanding faster and faster until it eventually rips apart. That's the essence of the Big Rip theory. But we're not just talking about galaxies getting torn apart here. We're talking stars, planets, and even atoms themselves. The evidence for this theory comes from observations of distant supernovae, which have suggested that the universe's expansion is indeed accelerating. This acceleration is believed to be driven by a mysterious force known as dark energy. As this dark energy continues to dominate, the rate of expansion would increase until everything is ripped apart. What does this mean for the future of the universe? Well, if the Big Rip theory is correct, the universe's fate is rather dramatic. In the distant future, galaxies would be torn apart as the space between stars increases exponentially. Eventually, the stars themselves would be ripped apart, followed by planets, and finally, atoms themselves. But don't panic just yet. The Big Rip, if it happens at all, is not expected for another several billion years. So, we have plenty of time to explore, learn, and perhaps even find a way to survive this cosmic catastrophe. In this scenario, the universe would meet a truly dramatic end. The Big Rip theory paints a picture of a universe not gently fading away, but violently tearing itself apart. It's a reminder of the ever-changing nature of the universe and our ongoing quest to understand it. These theories, each with their own chilling beauty, offer different visions of our universe's end. We've journeyed through the chilling specter of the Big Freeze, the crushing inevitability of the Big Crunch, and the terrifying prospect of the Big Rip. Each of these theories presents a unique perspective on our universe's ultimate fate, a testament to the vastness of cosmic possibilities. The Big Freeze suggests a future where the universe expands indefinitely, growing colder and darker until all energy is evenly distributed. It's a silent, icy end, where the stars burn out one by one, and life as we know it becomes impossible. In stark contrast, we have the Big Crunch. This theory imagines a universe that eventually stops expanding and starts contracting, pulling everything back into a singularity. It's a dramatic end, a final curtain call where every galaxy, star, and planet is drawn back to the cosmic stage from whence it came. The Big Rip, on the other hand, foresees a universe torn apart by its own expansion. Here, the very fabric of space-time is ripped apart, and everything from galaxies to atoms is shredded into oblivion. Each of these theories is backed by years of scientific research, complex mathematical models, and observational evidence. Yet they also underscore the vast number of questions that remain unanswered. What is the true nature of dark energy? How will our understanding of the universe evolve with future discoveries? How do these theories intertwine with our concepts of time, existence, and reality? In the pursuit of these answers, scientists continue to probe the cosmos, pushing the boundaries of our knowledge and technology. As we delve deeper into these mysteries, we not only unravel the secrets of the universe's end, but also gain insights into its origins and the fundamental laws that govern its existence. As we ponder these potential endings, we are reminded of our place in the cosmos and the grandeur of the universe we inhabit.